All right. Hello, welcome. And here we go on Containers from the Couch. Exciting episode today. We're announcing new MCP servers for Amazon EKS, Amazon ECS, as well as AWS Lambda. I'm joined by awesome guests from AWS today, product managers, engineers, and of course, we're going to be talking about MCP, Model Context Protocol. Um, Initially announced by Anthropic, I think November of last year. We saw widespread adoption of MCP across AI assistants and data source providers all over. Really, we saw that pick up over the last few months. Today, we announced again Amazon EKS, ECS, and serverless MCP servers, allowing you to get context from these services directly in your code AI agents. Okay, without further ado, I want to introduce my guests here. I want to start with each of you asking you a little bit about what you do at AWS and what you're going to be talking about today. Steve, I'll start with you. What do you do? And maybe explain MCP in your own words.
Yeah, so hi, Steve Kendricks. I lead the product team for the Elastic Container Service, Fargate, a few other services here. So I've been a product manager here for about 7 years now. Happy to be on the show here. The MCP, right? So MCP, like you said, was developed by Anthropic, and they like to view it as like the USB-C, right? That's how they frame it. Like it's USB-C for Gen AI agents. And so effectively you think of like a common standard that allows MCP agents, hosts, and servers to kind of talk to each other and understand the context for how they should operate. So if you think about it, like MCP, or I should say Gen AI agents are super powerful now. You can go from just an idea, if you're vibing out on coding and you're going from an idea of like, I just want to create a web app and it does this, and I want to deploy it somewhere, it can walk you through those processes and it can get it deployed pretty well. But that doesn't necessarily mean that it's doing it in the most either streamlined way, right? You're going to get a lot of questions about what you want to do. You're going to get a lot of like, oh, actually, I tried to deploy it this way and that didn't work. We're going to deploy it in a separate way now. Let's try that and see if it works. What MCP servers allow these tools, these agents to do is to effectively get real-time context into capabilities and maybe a little bit of an opinion about how that Gen AI tooling assistant can actually accomplish what the user is really trying to do with actual context of, hey, right, like you're trying to deploy to Lambda. I know how to do Lambda because I've got this MCP server installed, right? Or I know how to do ECS or EKS. I know how to containerize. I know how to troubleshoot. That was a longer, explanation of MCP, but that's generally how we view it, and that's what we're going to show you today.
Love it. Thank you, Steve. And yes, honestly, these LLMs, these AI code assistants are only as good as the context you provide them. So honestly, data really is the most important thing here. And I know that even when I'm building my own prompts, I spend half the time sourcing data to make sure my prompts and the agents have the information they need to give me a meaningful response. Okay, we're going to go to my next guest here, Balaji. Tell us what you do at AWS and what demo are you planning to show us today?
Yeah. Hey everyone, I'm Balaji. I'm a principal engineer at AWS. I'm a founding engineer of EKS as well. Like I've been here for like more than 10 years now. And I kind of lead most of the product within EKS. And today we have built an MCP server where you can connect our EKS MCP server to your LLMs, and then it can go perform like operations like EKS. It can go create an EKS cluster for you. It can update your EKS cluster, delete the EKS clusters, and similarly, it can also go operate on your Kubernetes objects. So it can go check your pod health, like service health. So we are going to like show you like how from a no code experience, like how you can get to it and deploy your application on top of EKS and use Kubernetes APIs to troubleshoot your issues. So should I get started with the demo or like?
Balaji, give us 1 second. We are super excited to get to the demo.
Sure.
But real quick, Karan, tell us what you do at AWS and what demo are you going to be showing us?
Hey, how's it going? Yeah, I'm Karan. I'm a senior engineer on the ECS developer experience team. So we work on everything from CDK, CFN, Terraform, GitHub Actions, and now we're working on MCPs. So super excited to demonstrate how our MCP server can help any developer, whether it's a vibe coder launching their first application that they want to share to the world, or an experienced ECS veteran DevOps persona. They can troubleshoot, maybe even the most intricate of issues with our tools. So yeah, I'm super excited to show off what we have.
So cool. I think I've seen a sneak peek of some of the stuff they're going to show today, folks, and you're not going to want to miss it, showing how to troubleshoot issues basically automatically, vibe coding to the max. It's pretty cool stuff. And Carlos, I would pay money to see someone make an AI remix of MC Hammer. You can't touch MCP. I want to see it. Okay. Let's go with one more question before we get into the demos, because Steve, can you quickly talk about what exactly are we launching today? What makes it special? What's new about it? And tell us how we landed on this type of solution, as opposed to maybe having released these as one combined solution or hosted servers and all of these different ways we could have done it. Why did we choose the way we did it?
Yeah, so specifically, we're releasing several MCP servers, like you said, ECS, EKS, Lambda. We've, what we're calling a serverless MCP server, and we've also released one for Finch, which is an open source kind of container building capability. So several MCP servers, and we released all of these on our AWS Labs GitHub. And the reason we did that is for two reasons. So one, specifically, we're moving fast. We really want to iterate on these things over time. Right, if you want to pick up, right, if any of you out there want to pick up and start playing with it and maybe contribute back and say, hey, like, here's something that I experienced when trying to use the MCP server, like maybe we can include this in context, right? We'd be happy to incorporate your feedback there. But two, there's also kind of like, if you think about MCP servers, they have these things called tools, right? Tools is kind of a first-class architecture concept within MCP server. A tool is what enables a think of it kind of like a command or a capability, right? And it says, hey, Gen AI agent, right? Q developer, your user wants to check the deployment status in EKS or ECS. This is how you do it, right? So that might be a tool. And there is a limit to the number of tools that can be active in a Dev AI an AI agent at any given time, right? And if you think about it, like a tool kind of eats into that context window that the Gen AI agent uses in order to actually process and deliver results back. So you don't want to overwhelm it with a very large number of tools. And so separating these MCP servers out into different capabilities really helps streamline that, right? We try and keep the number of tools low. So right now, like, that's just kind of best practices that we're discovering. In the future, we may change it. In the future, we may have a more centralized MCP server. But that's just the deployment approach that we took for these releases today.
Awesome, makes sense. And I'm very curious to hear more about that, Steve, about those tools, because the first thing I thought when I thought, they're automatically pulling CloudWatch logs and metrics for me, I was thinking, wouldn't we overload the context window basically immediately? So whether you want to answer that question now or after the demo, I'll let you decide, or through the demo. But Balaji, how about we start with you and we do the EKS demo of the new MCP server. Let's see how it looks.
Yeah, that sounds good. So before I show the demo, I wanted to quickly talk about the tools that the EKS MCP server has, and then go over like what are all the different things that we are going to see in the demo, and then go one by one. So first, like with respect to like the context window conversation that we are having, so what we did is like in Kubernetes, there are multiple objects. You have pods, services, deployments, stateful set, replica set, etc. So we don't want to like create separate tools for each of these, because the way it works is like when you start your agent or your LLM, like it gets the context of all the tools that are available, and we don't want to like overload your context window with all the different tools for each of the specific APIs that's available in Kubernetes. So instead, like we came up with like this high level tool called like a manage k8s resource, which takes like an argument like read, create, replace, patch, or delete, and respective like whatever the Kubernetes that you wanted to go access for. So when you pass those parameter, it'll go access those specific objects, and then it will return you that data. Similarly for EKS, like we don't want to like have separate API, so we have a one tool called manage EKS tags, using which you can create, delete, describe, and update the EKS clusters as well. And similarly for the Kubernetes resources, like we do have few other APIs, like where you can go list all the Kubernetes resources using just one tool, and then you can also go get the pod logs, pod events. And apart from that, we have also seen a lot of our users having trouble like getting the CloudWatch logs and metrics, and then updating the IAM policies for the Kubernetes controllers if they need to access any of the AWS resources. So for those, to make it easier, like we have few tools that'll help with their troubleshooting. And then I'll also show a demo on like this search EKS troubleshooting guide, where we have a hosted service. It provides data about like EKS and troubleshooting EKS issue. Like for example, if there are any products that we launched after the LLM was trained, then this particular troubleshooting guide can actually give more data to the LLM to help troubleshoot. So these are all the tools we have, and then we'll see how these tools work in action. So the first one,
Balaji, sorry to interrupt, just really quick question, just so I make sure I understand these tools correctly.
yeah,
The end user doesn't have to explicitly call these tools. They can just pure vibing, interact with the AI agent, and it'll figure out the tools it needs to leverage, right?
Yeah, that's exactly right. So that's what I was going to show next. So for example, like we have open sourced our EKS MCP server already, so customers can go use it on their whichever like the client that they wanted to use. For example, I'm going to show it on how client works. In client, there's this mcp.json file where I need to go just add this particular MCP server. So once I add this MCP server, you're going to see something on your installed MCP servers, and then there you can see all the list of tools that are already available. And for now, like I've enabled auto approve for everything, so that I just don't have to click approve for everything. But I'd be cautious if you're running it on your production cluster. So these are all the tools that my MCP server has. And now if I go to my chat history, I just have to type to LLM saying, hey, can you go investigate this issue? Then LLM actually knows that, okay, these are all the tools that I have, and then it goes automatically invokes this. So user or customers, they don't have to go invoke any of the tools.
Got it. And Balaji, we did get a question here. So since we have all of these published as separate MCP servers, to integrate them or to leverage them in one code repo that has multiple types of applications, you would just add more MCP servers here?
Yeah, that's what we are thinking for now, but we are also like getting more feedback on like how to like combine these MCP servers, because the more MCP servers you combine, more tools, and it's also going to increase your context window. So we wanted to be a little cautious of that. So yeah, but we are working on like trying to get some MCP server which works across all the AWS services.
Got it. And Carlos pointed out that flag allow write lets MCP do the actual edits. I think we had a question earlier about how to force this to be read-only in case you don't really trust it to let it loose in maybe a production environment.
That's a good point.
You don't have to give it permission to write.
Yeah, that's a good point. Sorry. So only for the EKS MCP servers, we do have two flags. One is like read is enabled by default all read operations. But then if you wanted to perform any write operations, you can also say allow write, and that will enable tools that performs write operations. And we also have another flag called allow sensitive data access, because for example, like pod logs, pod events, or the CloudWatch logs, everything that we get, we pass it to the LLM, and then LLM may get these information. So you might have a sensitive information. So that's why we added these additional flags where you can turn off if you don't want mutating operation, if you just want LLM to go troubleshoot the issue for you and then give you a summary of what's happening in the cluster.
Awesome. Makes sense. Okay, I think we've distracted you enough. Let's see how this works.
No, that's fine. So now I already have like a simple Python application that just says you hello world when you hit the query, when you hit that endpoint. And I already have a Docker file that built it, simple Docker file, and then I pushed it to my ECR repo. So I'm going to like say to my LLM, hey, I have this particular Docker image deployed on my cluster, and this cluster doesn't exist now. So let's see how this one does. So it's first analyzing my input, and then it's saying, okay, so deploy this. I need the Kubernetes YAML file, and then I need to like apply it on an EKS cluster.
Is this a dry run or is it going to do the thing?
It's going to do the thing.
Okay. But you can do dry run if you wanted to check, right?
Yeah, so dry run, like for troubleshooting, it's possible you just turn off the write and then you'll be able to see what it does and then gives you a summary. But yeah, for this one, we need.
Got it.
This.
So I think the interesting thing about this is it's getting context from not only your code base, but from the cluster itself. So for example, I think, let's say we could build the image for ARM-based instances or AMD 64-based instances. This has the intelligence to figure out what type of nodes we've selected, figure out the right architecture, and build the right image for the architecture, right?
Yeah, that's right. So I'll talk about that after this particular demo. So here, like first it figured out that, okay, it needs to create an YAML file and then it used the tool to create the YAML file. So if you see here, like our tool actually like gave an YAML file for the particular image with the port number and everything. So now it's going to like go deploy that particular image on my cluster. So it tried to deploy it on my test 3 cluster, and then it said, okay, cluster is not found. So it's trying to see if the cluster is actually existing or not, and then this says that, okay, cluster doesn't exist. So now it's going to go generate the cloud formation template to create the test 3 cluster. So once that is created, now it's going to go deploy that particular test cluster. So now if you see in my cloud formation, you will see this test 3 cluster is started, and then now it's provisioning all the required resources to bring up the cluster. So because the cluster creation takes a few minutes, so I also have another cluster that we can use for our demo. So I'm going to paste the same prompt, but then I'm going to say this time I'm going to say deployed on my test2 cluster. So test2 cluster was already pre-created, so it's going to deploy it over there. And
this is awesome. You don't even have to update the kube config or anything. Just tell it the account and tell it what you want to deploy. This is,
that's true.
vibes.
Yeah, that's true. So the cluster, the EKS clusters that the MCP server creates has the auto mode enabled already. So now when I say, okay, deploy this particular one, and if you see here, I don't have any nodes on this specific cluster right now. And then now it's analyzing my code repo, and then it says that, okay, now I already have a allo app manifest YAML that is generated. And then the image is set to the right one, the port number is set properly. So now it's trying to apply that particular YAML. So if you see here, now when I do the get pods, you'll see those particular 2 YAML files, but both are in pending state because it's an auto mode. It watches for your pods in pending state and then creates a node. So it's trying to now wait for the nodes to be up and running.
So it was intelligent enough to figure out that we're deploying to an auto mode cluster. So it doesn't need to, spin up a managed node group or anything like that. It just knows that, deploy this YAML and it'll get picked up by the general purpose auto mode node pool.
Yeah, exactly. So it's trying to see like why the pod is stuck in pending. It says that, okay, there's no node available. Then it's going to go do the get nodes, and then by that time Carpenter would have got the nodes. So it knows that, okay, now there's a node. Now this pod should be scheduled onto that node, and then it'll say that, okay, now the pod has been scheduled already. Yeah. So if you see here, it said like the node was just recently created. So now you can see here, good news, the node is now in create state. And now it's trying to see if the pod is now going to the pending state, from pending to running state. And in the meantime, I'm also going to deploy another pod for our testing purpose.
I love that it's just rapid fire LLM invocations based on new context, new data coming in. It's not going to be satisfied until the pod is up and running, right?
Exactly, that's true. So now it sees that both the pods are up and running, and then now it's trying to describe the service endpoint, and then it said, okay, here is your service endpoint, and then it says, okay, I've deployed your app now. It's running behind a particular DNS name. If you want to go query the DNS name, it also gives you the DNS endpoint. So we're just going to go query that and see. Let me see if this 5,000. Yeah, if you see here now, now the service is actually responding. So from like no knowledge of how to deploy my Docker image to EKS, now I was able to deploy my Docker image onto top of EKS. It created a cluster, it deployed it automatically, and then it gave me an endpoint to go access my particular service. So for the next one, like what I'm going to do is like I have another cluster. So this is like a common problem that we see. Like you create an application, but your application end up in like a crash loop back off state. And then you go figure out, okay, what should I do next? Like whether I should go look at the pod logs or whether it's there in CloudWatch logs. How do I go investigate this? But instead of that, like now, let's see how does the LLM does in this case. So I'm going to go say to LLM, okay, so I have this Nginx pods that are in like crash loop back off state in this per pod cluster. So now I'm switching my cluster to a different one. So same like before, I don't have to run any kubectl command or update kubeconfig command. So I'm just going to say to LLM, hey, can you go figure out the problem why it's in crash loop back off state? And the nice thing about these LLMs is that like when they start, they go from the basic. They go do get pods and then see if the pod has a deployment. They go read the deployment object, and then they go get the pod logs, pod events, and then they summarize. Okay, this is what I found so far. So if you see here now it's trying to do the list pods, and then it got list of pods.
And so it's using the troubleshooting tool now. That the of the tools you showed us earlier, this is one of those.
Yeah, it's using one of them, like the pod
Okay.
logs. It's going to use the pod logs, pod events, all those things.
And so when it runs a command like, to get the pod logs, how does that not overload the context window, right? Like, does it know to semantically find relevant logs? Like, how does it work?
Yeah, so it depends on the tools as well, like with the description that you provide in the tool, and then like the time frame that you provide in the tool. But in this specific case, like the pod logs doesn't have much, so it's not going to overload the context. But it's mostly depend on like what the tool can take and then what it can provide.
Got it.
Yeah, so if you see here, like it figured out from the pod logs, okay, there's something going on with the pod logs. I see the exact issue now. This is the specific API. It says like there's no such API. And then now it's going to go check the deployment to see if that's correct. So it checks the deployment. And then now it says, okay, I have the full deployment spec. Now I can see the problem with your YAML file, why it's failing. And then it says that, okay, you created this particular /health-c API, which does not exist. You should either change it to / or /index.html based on the image that I'm using. And then now it's saying that, okay, now I'm going to patch your deployment. So it's automatically patching my deployment now. And now it's checking if the pod is now coming up fine. And yeah, by the time over here, if you see here from the crash loop back off state, now it's went to running state. So
nice.
Yeah, so now I can just do an exact into to have a now if you see my pod is now up and running. And then it gives you a nice summarization of, okay, hey, this is what I found. Like I found that you misconfigured your endpoint. I configured it properly. Like I removed this, and then now the pods are up and running. Now you can go hit your endpoint. So if you have a DNS name, now it will start working. So that's the other pretty cool thing.
That's really cool. The troubleshooting aspect, it's wild. The way I see it, it's with these MCP servers, we basically voice activated our EKS clusters, right? Like we could chat with them, which is
exactly
incredible to me.
Yeah.
By the way, Balaji, what AI LLM model is powering the behind Klein here?
This one is using the Bedrock service, and then it uses the Anthropic Cloud.
Okay, is that 3.7 Sonnet?
Yeah, 3.7.
Oh, nice, awesome, and that's customizable, right? You can use
Yeah.
Okay.
And then the last one I wanted to show, for example, like we had this EKS auto mode launched in like reinvent of last year, but then like most of the LLMs that I was using for my testing at least was like trained before the EKS auto mode. So it was struggling to figure out what is EKS auto mode, like what are all the configuration it has. And if there is a trouble with the EKS auto mode, how do I go investigate? So to help these LLMs that was trained before it was the product that was launched, so we have a separate tool. That's what I was showing you earlier. It's called like this, the search. It's over here. the search EKS troubleshooting guide. So we have a knowledge base on our side with all the troubleshooting that we have seen from the past. So now if LLM doesn't know how to troubleshoot a problem, it uses this tool and then says, hey, here's my query. Can you tell me what should I do? And then our service responds back with like list of steps. And then LLM uses that to provide better troubleshooting guides for our end customers. So we'll see how this tool works. So now I'm going to I have another cluster where, so to give you some context on this, so I have a cluster called my test, and then this uses a cluster role, so and so, and then in that cluster role, like I removed all the permissions that is required for that particular cluster to act. So if I go here, so if you see here, like for EKS auto mode to be to run successfully on your cluster, you need like 4 to 5 IAM policies to be associated with this cluster role. So I've removed all those. So if I go to my so if you see here, there's a pod that's stuck in pending, but then the carpenter that's running on this particular EKS auto mode is like is having some issues to launch a new worker node. So what we are going to see is if I give that particular prompt where I have this simple nginx pod and default namespace and auto mode is not able to launch a new instance type, it's going to now go do a bunch of same operations like get pods, get logs, and then for carpenter, it does know that, okay, now it needs that node pools, and then from node pool, it goes to the node class objects, and from node class, it figures out there's a problem, and then that's when it calls our backend service to see, okay, I have this particular problem, what are all the things that I can do? And then our backend service says, oh, these are all the 5 steps that you might want to go try it out, and then it does that, and then based on that, it provides a better output, and then says, hey, maybe you want to just go add these policies. So it's just going to take like 2 minutes to get to that conclusion. So we can just quickly.
Got it. And so, Balaji, I had a question on this. So you kind of explained how this troubleshooting tool that we've kind of pre-programmed it with like our knowledge base and the right APIs to call in AWS and kind of our approach to debugging. And you got to expect customers probably have their own set of debugging documentation for their own, Snowflake environments and their unique considerations and requirements. Can customers extend these MCP servers to add their own knowledge bases, their own troubleshooting techniques as well?
Yeah, they can. So similar to how we did, like all they need to do is like have a tool, and then that tool needs to go scrape from their particular knowledge base and then give the data back. So all we did is like something similar to, like we have a knowledge base with all the list of issues that we have seen in the past, and then we give to our backend service, and then that's going to search from our data store and then say, hey, for this specific issue, maybe this is what you need to do. So they can just do that as well.
Yeah, what's cool about that is it's this tool will only ever get better. It'll only ever get better at troubleshooting and solving problems, which is awesome to think about. Yeah. Okay. There is an interesting question that we got in the chat. So while we wait for that to go, kind of an open question for all of us here. So instead of it patching Kubernetes resources directly, can it integrate with other GitOps solutions, other GitOps MCP servers, so that these aren't like ClickOps style changes, but actually integrated into an automation workflow?
Yeah, it can actually. Like that's something that we wanted to extend as well. So whatever we have right now is like the basic tools to like get some initial feedback, but then we do wanted to integrate with the other components so that we don't have to like put everything inside our tools, and then we utilize whatever is there outside upstream.
Got it. Makes sense. Because in most cases, when you're debugging issues, you probably won't want to apply the changes directly to Kubernetes. You want to make sure that you're applying it to the source of truth, which in many cases is in GitHub, which I'm guessing it's a small edit to have it do that instead of apply the changes directly.
Yeah.
Okay. Do you want to quickly tell us what's going on in that chat window? What's it figuring out? What's taking so long?
Yeah, so this case, like it doesn't know, like the EKS auto mode does not run on the cluster actually, like it runs behind the scene. So it's trying to figure out like where the the carpenter logs are, like where the in which particular namespace the carpenter is running, so that it can go figure out the logs. So it's going to do a bunch of things, and then it's going to say, okay, no, I'm not able to find the carpenter, but then now I found the specific issue from the node pools, node class. Maybe now I will use the search tool and to see like if I can get more data from the search tool.
It's actually uncanny how aligned that is to how a standard Kubernetes operator would debug that issue as well. They would start by looking for the carpenter logs, realize that, hey, that's not available here. Let's find another
maybe
approach.
Maybe in the interest of time. So I also have this one. So without our tool, like first I turned off the tool, and then without the tool, like it went and figured out, okay, so I found from the node pool, node class, I know that there's a specific create fleet permission that's missing. So it now using that particular the search tool that I said, and then says, hey, my controller is not able to call this. What should I do? And then our tool says that, okay, these are all the things you can try. And then we also have a tool description that says that maybe invoke this particular API 2-3 times so that you get more data. So it does that. It calls multiple times. It gets that data back, and then now it's trying to summarize. So when it summarizes, you can see here it's still trying to get the data, and the good thing that we see is that when it summarizes, you can see here that I need to go back. Yeah. So this was like with the tool that does not have the data, where it summarizes and then it says that, okay, for you to work, one second, sorry. Yeah, it figured out that, okay, the EC2 create fleet permission is missing, but then like it didn't have access to the tool or. Yeah, so this one, I'm not sure which tool I'm looking, which search history I'm looking at, but maybe this one. Right one. Yeah, so over here. So after using all our tools, then it figured out, okay, now from the troubleshooting guide, I can figure out that, okay, your nodes are not launching and you have a create fleet permission. And then the guide says that you need to have these 5 policies attached. And then now it's trying to summarize and saying, okay, I found from the node pool, node class, that your node is not ready, and then it's missing this create EC2 fleet permission. And then from the troubleshooting guide, I found that these are all the permissions you need. And then it says that make sure you add these permissions, make sure you add this particular service principal as well. And then it summarizes it. And what we have seen is like without that tool, like it just says that, okay, now you have to go add the EC2 create fleet alone to that particular cluster role. And then after create fleet is added, now it goes and says, okay, now you want to add this one more IAM policies. But with the tool where we provide like list of things, it says that, okay, instead of adding one permissions at a time, maybe just go add this managed policy so that it has all the permissions, and now Carpenter will be able to launch new nodes in your cluster.
Awesome.
So that's the advantage of the search tool that we have, where we also like go through our internal data store and provide LLMs with more data that it can help with this troubleshooting.
Super cool, Balaji. Thank you so much. You know, this actually reminds me of this old XKCD comic of a programmer getting yelled at by his boss to get back to work. He was goofing off, and his excuse is, my code's compiling. And I can already see it now, that the new excuse is, my AI agent's working on it. I'll get back to me in a few.
Right.
It's great.
Yeah.
Okay, so we've seen the EKS MCP server demo. Karan's going to show us the ECS MCP server demo. Before we jump into it, Steve, off to you real quickly to preface a little bit. Tell us what we just saw and what we're going to be seeing with ECS. How is it different? And kind of what can customers expect to do with this tool?
Yeah, so generally speaking, right, like if you think about how, right, the differences between EKS and ECS, right, EKS is built to be the best way to run Kubernetes, right? Like that's generally our mission with that. And so you kind of need to build it with context of Kubernetes concepts of Kubernetes, just how it works. And then obviously EKS on top of that, like, specific configurations, right? So what we're doing is we're giving those Gen AI tools that context. right? With ECS, it's a little bit different, right? ECS we view as like an AWS native capability, right? Super simple and easy to get running, building applications and getting them running into the cloud with Fargate. And so what we're going to show you with the ECS MCP server is effectively like how to build that app, right? And then go down to troubleshoot it using Fargate, kind of as that first choice, right? For that simple way to run it. So over to you, Karen.
Let's see it. ECS already the easiest way to run containers on AWS. I think we'll see it get even easier, right? Let's take a look.
Cool. Yeah. So before we jump into the demo, we'll go over a bit of the tools that we've included in our server. So we include both deployment tools and troubleshooting tools. In the deployment tool, we'll demonstrate the containerized application tool, which helps guide the actual creation of the Docker files. Then we have a create ECS infrastructure tool, which is very useful for creating a CFN template with all the secure defaults that we recommend, and help customers create that correctly and also deploy it. And then we also have deployment status, which can help pull basically the creation of that infrastructure. And then for rapid prototyping that maybe vibe coders want to do or other organizations, there's also delete ECS infrastructure that they can use to tear down after they're done with their workflow. And then we also want to address some of the customers that really like to diagnose maybe deep ECS issues that aren't very clear to understand. So we have a variety of tools here that aggregate basically different logs and provide guidance on how to troubleshoot a failing task, for example, or a failing service. So finally, we also have a read-only tool over here called ECS Resource Management. In the future, we will also try to create and update and deletions to it, but this also aids the troubleshooting experience for the AI assistant as it is. So let's jump right in then. So I'm gonna demonstrate basically a typical vibe coder workflow. So this is the mcp.json config file that is typical for most AI clients, and I'm going to use Q for this demonstration. As you can see here, we've configured that we're using the ECS MCP server. We have our profile and region. And if you look at the app that we're going to deploy, it's a simple to-do application that I vibe coded earlier. So pretty simple, straightforward. It's just an Express app. As you can see, though, there's no Docker file, no Docker Compose file. So we've done no containerization, but we're going to see how Q can help us. So, and more specifically, the ECS MCP server. So I'm going to enter Q chat over here. And
Karan, if we can make it a tad bit bigger.
Absolutely. All right.
Perfect.
Hopefully y'all can see this. As you can see, the MCP server got initialized over here. So I'm going to ask it a pretty simple question. So how can I share my app to the web? And now Q is going to do its thing. All right. So because we have the MCP server installed, it automatically suggests to using ECS, and it's going to guide us through how to do that by using the tools that we have. So let's give it a second to read through what sort of application we're dealing with.
I'm curious to see what it picks, because there's, probably I can count on more than two hands the number of ways you can actually deploy to ECS. So I'm curious what it's going to suggest.
Yeah, that's something we're working through. Like when you have multiple MCP servers, what's the best choice to do? So stay tuned for that. But for now, we just have ECS here. So it's picking ECS basically by default.
Nice.
All right, so this is basically going to give like our best guidance on how to containerize an application. So it automatically suggests to use Docker over here. So using our guidance, it notices, like, unlike the AI assistant might typically do, it's going to pull from the public ECR repository over here. So it looks good to me. I'm going to say yes. And now we got a new Docker file. And then some other suggestions that we provide within our tool is to create a Docker Compose file. So it's going to do that for us as well for easier local debugging. So this is great. We now have a Docker file and a Docker Compose file. And maybe the next step would be to actually try to create infrastructure for this. So this tool over here, as you can see, has a few parameters. It includes our port number. And then we have also included this thing called force deploys false. So when force deploy is false, it's basically a read-only action over here. So it's going to create CloudFormation templates for us, as you can see over here, for ECR and ECS. And now it's going to basically give us instructions on how to actually deploy this to ECS. So obviously that's a multi-step process. It requires creating ECR infrastructure, then actually building and pushing the Docker image and deploying the ECS infrastructure. And we've included an ALB in here so you can get a default URL back. However, we also have the more automated approach, which it's correctly suggesting here, to run with force deploy is equal to true, which will do all these things. So how about we say, yes, please force deploy.
So it'll update its own configuration based on the prompt you give it.
Yeah, so I mean, basically before all that happened was it created the CFN templates and it allows the user to do whatever they want to with that. With this, it'll actually deploy by running the actual CFN commands to deploy, as well as build and push the image to the ECR registry. So step one, it's going to actually create the ECR stack. So I'm going to show, this takes a bit of time because it is CFN. So let me go ahead and access the console. All right. Let me zoom in. Let me know if this is good.
Looks good.
All right. So if we go to CloudFormation over here, we can see, okay, cool. The ECR infrastructure is in process. While this is creating, I think it might be interesting to go through the template that we have over here as well. So you can see it creates a few things, a new role for one that's scoped down to pushing to this registry and is provided to the MCP server and the customer at the end of the day to actually push to the registry being created. Then we also include ECR encryption by default, which is using KMS under the hood. And that takes a while to deploy, so that's why it'll take probably another 30 or 40 more seconds. And then alongside that, we include the role that we mentioned earlier. And then our ECR repository has a few things here that are very useful that maybe by default, the customer might not know to actually configure, such as image scanning, as well as image tag mutability. And of course, the customer can change all these things as they see because it is CFN, and it will actually go through and deploy those changes as well. Okay, cool. So it looks like we are done. All right, let's do the next step over here. So what this is going to do is also take a little bit of time, but it is going to actually build and deploy the image in Docker. Today it's just Docker, but in the future we are going to integrate with Finch as well to allow basically the build and deploy to happen from there. So I think the best way to probably inspect this would be to go to the ECR repository over here. And we can see here, okay, cool, successful. It deployed a new Docker image. It's tagged, not using latest, which again is also sort of not best practice, and it will create a unique tag per deployment based off of epoch. Okay, and then last but not least, let's actually deploy the ECS stack that we have over here. And this is going to take a decent amount of time just because of the nature of all the infrastructure it is deploying. So if we see here, it started that, and I think it'll be interesting for people to see all the different things that are being configured. So even though ECS is probably the easiest place to deploy containers, there is still a lot of infrastructure you need to configure beforehand, right? So especially if you want to get it publicly accessible on the internet. So we have over here a few things. We have the ALB itself, which also includes quite a few different pieces, including listeners and target groups. We've created security groups for the ALB as well as best practices. We have CloudWatch groups for the actual ECS tasks to run in. And then rather than using the private subnets with a NAT gateway, we've actually included VPC endpoints, which are sort of a better method to get access to the internet for your ECS tasks. Then you got the clusters, of course, security groups, and then we have the ECS service itself, which includes some security defaults, including circuit breaker, managed tags, and we also have container insights by default on the cluster, as well as using Fargate. So as you can see, a lot of things that can go wrong, especially for a vibe coder who's just trying to get started to get their application up and running. This has taken care of a lot of that groundwork and is basically automated the customer all the way through.
So Karan, while it finishes creating, a quick question. So when Balaji was showing us the demo, at least in most of the demos, it seemed like the agent would incessantly call API requests and wouldn't give up until it was done. But I noticed the behavior of the demo you just showed us. It stops often and double checks. Are you sure you want to do this? Can you confirm you want to do this? Is that explicit in the behavior that's programmed into this tool, or is that just from the way you demoed it?
Yeah, so basically, I think what Balaji was doing was he trusted a client to just go bam, 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 and it'll execute. Over here, I'm giving my consent, which is the default behavior for most AI assistants, where I need to actually allow, like, say yes and affirm that I want to do an action. But also our tool, we've taken a sort of slightly different approach where we're doing a very prescriptive best practice approach to deploying infrastructure. So we're excited to get more user feedback on this approach versus, just allowing the assistant to run the APIs in a different fashion. So
I will say that I was more lenient than Karen when I was testing this and allowed it to trust, and it did go bam, 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 like all the way through, and it definitely deployed things very, very quickly, which was very impressive. And you also, whenever using Gen AI coding assistants, do be sure you do trust it and you know exactly what it's trying to do.
Yeah. So I think while this is running, because this will probably take another 2 minutes or so, we can go ahead and show the troubleshooting aspects as well.
Yeah, at least like on the previous topic side, like at least for the Kubernetes, like because when you wanted to troubleshoot, you have like pods, deployments, replica set, logs, events. Like if you can at least auto approving the ones that we trust are like much better. Otherwise, you have to just go keep doing one after the other.
Yeah, I totally agree with that. I think also the cool thing that you can do on both of our tools is we can set the allow write or allow sensitive to true or false. So
Yeah.
Especially for troubleshooting, it makes sense to set those to false and allow it to do things in a read-only fashion.
Got it. Well, we did get a question on this just a bit earlier saying, are there specific things that we can hand pick the model to perform? Like we're okay with it applying, deployment resources, but not service resources or ingress resources. Is that level of control available yet? Is that on the roadmap? How does that work?
It's not yet on ECS, but I think it's definitely an interesting idea. So whatever ideas like that, and bring them, keep them coming. Please definitely file an issue on our GitHub on the AWS Labs MCP repo.
Awesome. I'll drop a link to that. And folks, again, announcing it today, it'll only get better from here, and feedback from all of you from using it, it'll be critical to the way we shape these projects. So I'll drop the link in the chat here again.
Okay, cool. Well, turns out it took actually faster than I expected. So I'm going to go ahead and run this get deployment status tool over here. All right, great news. To-do app has been published. Here's a summary. So it gives me a list of all the different resources that were actually provisioned, as well as an actual link to access my application. Tells me how many tasks are running, and then it gives me next steps too, because obviously this is just more of the prototyping stage of a customer's journey. If they want to really productionize this in the future, they can set up a custom domain, set up HTTPS, and as well as CI/CD auto-scaling. And the LLM is more than capable of obviously helping guide you through the rest of that part as well. If we want, we can take a look real quick that I did not just hard code this demo. And yeah, here we go. Success. So pretty cool stuff. And we can pretty easily just say tear down my app over here when we're done sharing it and testing that it works. And this will use our other tool. Let's see. Yep, delete ECS infrastructure. And the cool thing about this is it'll actually validate the local stack that you have or the templates with the stacks that's up there. So it doesn't just delete any arbitrary willy-nilly stack, which again, we're trying to create good guardrails for AI assistants.
So Karan, I'm glad you bring up guardrails, and I see that it's cleaning up there. So awesome there. Open question for all of us. Looking at how powerful these tools are, and we've touted how much they're going to improve developer workflows. I want to ask you guys an honest question and give it to me straight. What are the demons lurking around the corner? What are the gotchas with MCP? Where do you need to consider things like guardrails and security and granting an AI agent permission over your environments? Steve, I'll start with you.
Yeah, I mean, for me, it's actually really interesting, right? I'm not an engineer by trade; I'm a product manager, and so, generally speaking, my thing that keeps me up at night is thinking that is trusting too much, right? We kind of talk through the, should you trust or not trust. For me, this is giving me personally, like I have gone through using the ECS MCP server, using just Q Developer or other AI coding assistants and created web applications on my own, right? Like that's how powerful these things are, and they can use ECS, they can use Fargate, right? Like, generally speaking, I think we're in kind of this space where I'm not exactly sure all of the guidelines that I need to make sure that I check, right? I need to make sure that I'm doing my due diligence on this, but since I'm not an engineer, I don't know what I don't know, right? And so that's one of the things I'm sure, and I'm sure generally speaking, that's just a matter of experience. As I get more comfortable, I'm going to learn things. And the same thing with engineers, as they get more comfortable using these things, they're going to learn how MCP, or how I should say, how dev tools tend to work and how they can tend to fail and how they can tend to do things wrongly. And so you just really need to make sure that you are monitoring, you're aware, you're being vigilant over what's actually getting deployed and into your account. Always check, right? Because like these tools are very, very powerful, and we are in some ways making it more powerful for them, making it easier for them to deploy. And that's very, very good from a certain perspective. Like Karen said and Balaji said, like we're giving it guardrails, but again, right, make sure you check, please.
Makes sense. And we actually just got a relevant comment on this too. So can't just someone use the MCP server to get a secret they're not supposed to have access to? I think I know the answer to this one. The MCP server only has permission to access the thing that the credentials you give it have permission to access, right? So it has access. You would expect your developer would give it the same amount of access that the developer would have. So it's not able to magically pluck secrets from some other account that you wouldn't have had access to in the first place.
Yeah. Just to speak more on that, I think one cool feature that we are adding, and I think a lot of MCP servers will as they evolve, is we redact basically PII and sensitive data like passwords, secret keys from actually being logged or even returned in the output. Which can be a concern. Hey, is my secure data being passed to the LLM, which maybe customers might not want.
Got it. Karan, Balaji, anything else to add on the security front of where we see these tools going?
Yeah, I think only thing is like when you're running it on your production cluster, make sure like you turn off the auto approves especially for the write operation, because as I was showing you in my demo, like I had an incorrect API endpoint, so it went and auto corrected the endpoint. But then in other cases where it had an incorrect endpoint, it actually went and changed the image as well, saying, hey, maybe don't use this image, maybe use another image, and it went and patched that deployment with that image. So we don't want that to happen in your production cluster. So make sure like you approve them one by one when you're doing any write operation on your MCP servers, using the MCP servers.
Yeah, I love the caveats. We have to provide the caveats here.
Exactly.
Another question here from Hardeep. What are the costs for deploying or troubleshooting using MCP? Just the cost for the invocation, right? The chat invocation.
Yeah, it's just it's entirely on purely on the client that you use. There's no cost on the AWS side because it just calls an AWS APIs or Kubernetes APIs, so there's no cost associated with all those.
I bet we're gonna see a spike in API requests to the Cube endpoints and the ECS endpoints that we host at
Yeah.
AWS. But
Yeah.
yes, there's reasonable limits there, which I don't think you'll hit anytime soon.
Yeah.
Okay, folks, with just a few minutes left here, another open-ended question. This stuff, game-changing, super powerful. What do we expect to see in the industry, like broad trends and how customers are leveraging EKS, ECS, and Lambda? Do we expect customers to better implement best practices? Do we expect them to be innovating more rapidly? What do we expect to see?
Yeah, we definitely do, right? We think best practices should go up, especially we've gotten some early feedback that customers are, struggling a little bit with their current capabilities, right? Like they just don't quite know what to do. But generally speaking, right, you're going to see more things like maybe a move towards more remote MCP servers, right? Right now, dev tooling doesn't, or AI tooling doesn't always work super great with remote MCP hosts. So like let's think about how we can serve these remotely, give best practices, do updating. Those are certainly things that the industry is looking at a whole. And then if you think of, again, like agent to agent communication, how do agents communicate with each other? There's definitely a story here with MCP and with other, kind of like LLM tooling, if you'll forgive that kind of expression, that makes it more capable, especially when communicating without user input, right? That's going to be a more critical capability, right? How do you set up the right guidelines so that your agents can interact with other agents without you, or at least without you knowing exactly, but you still get to review the results. And then again, like we talked about, there is a limit to the number of MCP tools that a IDE can have at any given time, right? So how do we overcome that? Is there a way to switch out the MCP tool or the MCP server that the tool is getting access to or using at any given time, depending on where it is? How cleanly can it do it, right? Like if you go try and install, it doesn't always install the same way just for the same server, right? And so, right, there is some standardization to do with MCP still, in terms of like just how these tools interact with the MCP servers. So,
Yeah.
Karen, anything to add?
No, I think the other challenge is that, like, say, when the LLM tries to troubleshoot an issue, it does like query multiple things, and then it comes up with its own summarization. Sometimes, like, the summarization does not actually like go along with what we wanted to do. For example, when I was investigating that EKS auto mode, like it said, okay, from the troubleshooting guide, okay, I got these policies to be added, but instead of adding it to the cluster role, it went and added to the node role. But then when I ran it second time, then it said, okay, now I need to go add it to the cluster role. So like figuring out like the things like the data that we need to send it back to the LLM so that it's able to troubleshoot the issues like how we wanted to do. I think that's the other challenge on like how much of data we wanted to send back so that it does not impact their context window, but then still like has the right amount of data for the LLM to troubleshoot the issues. I think figuring out that will be another challenge.
Yeah, absolutely. In my mind, what I think is going to be the real jump is when we can go from this type of supervised activity to unsupervised agents, just monitoring
Exactly.
your clusters, making actions, and I'm going to go ahead and say we're not quite there yet. It'll be some time before we fully trust agents, and I think the demos you saw today and the way these capabilities were implemented and shown today indicates that we're very much in a supervised state with these integrations with the LLMs with the models. But MCP itself was literally just announced about half a year ago, and so the future is looking insane. We're curious to see where all of this stuff goes. In the chat, I've posted the blogs for all of the MCP servers that were published today. There's actually a whole lot more. Check out the blogs if you're interested in getting hands-on, learning how these things work. I really want to thank our guests for joining us today, taking time out of their day to go through the demos, developing these demos, and giving us some insight. So thank you to all of my guests, and thank you to all of you at home that are watching. And we'll catch you next time on Containers from the Couch.
Cool. See you.